NCERT Physics, Class 11th, 7th chapter, which is System of Particle and Rotational Motion, question number 7.8. In this, we had given that a non-uniform bar of weight W is suspended at rest by two strings of negligible weight as shown in figure. The angle made by the strings with the verticals are 36.9 and 53.1 respectively. So the in figure where the angle is given with vertical, the length of bar is 2 meter. Calculate the distance d of the center of gravity of bar from left hand. So in this we are going to define the value of d, which is distance of center of gravity from left side. So first we are going to draw the free body diagram of the given situation, that let's say in this string the tension is T1 and in this string the tension is T2. Now taking the component of this tension T1 and T2, we have, if this angle is alpha and if this angle is theta, we can say that if this is alpha then this would also be alpha, and the component which is coming in this direction is T2 sine alpha, and the component which is coming in this direction is, this would be theta, and this is T1 sine theta, where the value of theta is 36.9 degree and the value of alpha is 53.1 degree. Now the system is in equilibrium, so by applying the condition of translational equilibrium, we have, by applying the situation of translational equilibrium, we have the net force in x direction must be 0. So fx, sigma fx is equal to 0. This implies that T1 sine theta is equal to T2 sine alpha. So from this we can find the value of T1 sine theta is equal to T2 sine alpha. And now from this we can find out the ratio T1 by T2 is equal to sine alpha upon sine theta. Alpha is equal to 53.1 and theta is equal to 36.9. On solving this, we have T1 upon T2 is equal to 0.8 divided by 0.6, which can be written as 4 by 3. So the value of T1 comes out to be 4 by 3 times T2. So in this we have the relation between T1 and T2. Now another situation which we can apply is the condition of rotational equilibrium. By applying the situation of rotational equilibrium, rotational equilibrium means the torque about any point must be 0. So if we take the torque about center of gravity about this point, if we take the torque about center of gravity, then we can say that, so by taking the torque about center of gravity, we can say that the torque due to T1 sine theta would be 0 as it is passing through this point. The torque due to T2 sine alpha would be 0. The torque due to W will be 0. So the torque which is coming is only due to T1 cos theta and T2 cos alpha. So by applying the condition of torque, we can say that torque about center of gravity, the torque about center of gravity is taken to be 0. So we can say that T1 cos theta into perpendicular distance of this force from W is d, and this must be equal to T2 cos alpha into perpendicular distance, that is total length is 2 minus d. So on putting the value of cos theta and cos alpha, as we know that theta is equal to 36.9 and alpha is equal to 53.1. On solving this, we can find the value of d, and the value of d comes out to be 1.2 upon 1.67. And from this, the value of d comes to be 0.72 meter. It means the center of gravity is at 0.72 meter from the left end.